1 minute. Okay, so I am sharing the screen. I have shared the screen. Check it.
Yes, sir, it is visible.
So yesterday we discussed about started SHM. Now here you can see that there are basically two types of SHM. First you will see linear SHM and second you is angular SHM. Now what is linear SHM? Linear. So if an SHM takes place about a fixed point and the particle moves in a straight line. For example, this block, if you will pull it, you leave it will oscillate in a straight line. Okay, then this is linear SHM. Here particle is going to and fro about a fixed point along a straight line. For example, motion of this block connected to the spring. Now the second type is angular SHM. In angular SHM, a system oscillates angularly with respect to a fixed axis. So here you can see that if you take a pendulum, okay, and displace it by some angle from the vertical and release it, what will happen that it will start oscillating and about its mean position. It will start going like this and coming like this. Here, if you see closely, it is not motion in a straight line, it is motion on a curved path. And here the angle with the vertical, that theta keeps on changing, right? So this is angular SHM. Okay. Now necessary condition to execute SHM. We already discussed in the last class that the necessary condition is that the force must be directly proportional to the displacement from mean position and directed opposite to the displacement from mean position. So if displacement from mean position is in the right direction, then the force direction will be in the left direction, opposite. Also, you can understand that force is always directed towards the mean position. Towards the mean position, always. At any instant of time, force, restoring force acting on the particle is always directed towards the mean position. And same goes for acceleration. Negative sign is only showing that the direction of force, or you can say acceleration, is towards the equilibrium position, and x is the displacement of the particle from the equilibrium position. You can also say that the direction of force and the direction of displacement from mean position, they will be always opposite. Till now there is any doubt? Now the next is about angular SHM. In angular SHM you have to understand, you know, that here force will not play the role, here torque will play the role. So force will be replaced by torque and displacement will be replaced by angular displacement, because here something is rotating about a fixed axis. So in angular SHM, the necessary condition is that the torque acting on the particle about the axis should be always proportional to the angular displacement of the particle about that axis. And it should be always directed towards the equilibrium position. Means the torque should be in such a direction so that it brings the particle back to its equilibrium position. Or you can say that the direction of torque and the direction of angular displacement, they will be in opposite direction. Because if they will be in opposite, then only it will bring back and oscillation will take place. So if you have any doubt in any one of the two, you can ask. So in place of force, there is torque, and here in place of acceleration, there is angular acceleration. In place of displacement, there is angular displacement. So initially, we will be discussing about linear SHM only, and then in the last part, we'll be discussing angular SHM and questions related to that also separately. Is it clear?
Yes, sir, it is clear.
Okay, so let's go to the next. Now, these are some of the basic points which you already know. Mean position, position where net force on the particle is zero, or also you can say that the potential energy is minimum. Here you have to understand that SHM takes place about the mean position, and mean position must be a position of a stable equilibrium, not unstable equilibrium. Mean position must be a position of a stable equilibrium. And because mean position is also a position of stable equilibrium, so potential energy at mean position must be minimum. I'm not saying must be zero, must be minimum. Are you getting it?
Yes, sir, I'm getting.
Ask your doubt.
I'm getting, sir.
Okay. Now the next is restoring force. Restoring force is only that force, or you can say resultant of those forces, which tends to bring the particle towards its mean position. Restoring force is always directed in a direction opposite to the displacement measured from mean position. So this is the restoring force. Now amplitude you already know, that is the maximum displacement from the mean position is the amplitude. Time period is the time required to complete one oscillation. Time period is 2 pi by omega, where omega is the angular frequency. Oscillation. One oscillation means a particle goes, starts from mean position, goes to one side, returns back, goes to the other side, and then again returns to the mean position. So this is one oscillation. Okay. Now, frequency is reciprocal of the time periods. That's it. These are the units. You already know these things. Now, phase. Now, this is very important here. Phase. This is very important. So, phase of a vibrating particle at any instant is the state of the vibrating particle. Now, what is the meaning of state? State means two things. One is what is its displacement from mean position, and second is what is the direction of velocity at that instant. So, for example, two particles are there, and both the particle have same displacement from the mean position, but one particle is going towards the mean position and one particle is going away from the mean position. Are both the particle in the same phase? No, they are not in the same phase, because their displacement from mean position is same, but their velocity direction is different. Are you getting? So phase is the quantity which gives an idea about what is the displacement of the particle at a particular instant and what is its direction of velocity at that instant. These two ideas are given by the phase. Now, general equation of SHM is x equal to a sine omega t plus theta. Any equation in this form will represent an SHM. Now here, the angle with the sign, that is omega t plus theta, this is nothing but phase of the particle. Try to understand that this omega t plus theta is a function of time. Phase is a function of time. Are you getting? So it will continuously change with time. And if omega t plus theta will continuously change with time, sine of omega t plus theta will change, and then x will change. So x is a function of the phase. Phase will change, x will change. What is x? X is the position. Are you getting?
Yes, I'm getting.
In the phase, if you put t equal to 0, what you will get? Phase is omega t plus theta. If you put t equal to 0, what is phase at t equal to 0?
But theta is before.
Theta. Theta is called as the initial phase. Okay. The difference of total phase angle of two particles executing SHM with respect to the mean position is known as the phase difference. So phase difference always comes when we talk about two particles. If two different particles are doing SHM, then only the question of phase difference will come. Now, two vibrating particles are said to be in the same phase if the phase difference is multiple of 2n pi. Why it is so? Because when the phase difference will be in multiple of 2n pi, then the position and the direction of motion, displacement and the direction of motion, both will be exactly same. And why they will be same? Because sine is a periodic function and it is periodic with 2n pi. So if you increase the angle by 2n pi, where n is integer, again you will get the same value of sine. Two vibrating particles are said to be in opposite phase if the phase difference is odd multiple of pi. So if the phase difference is pi or 3 pi or 5 pi, we say that the two vibrating particles are in opposite phase. Opposite phase means that they have opposite phase means they have the same displacement but in the opposite direction. From the mean position. So when a particle oscillates, the x, which is displacement from the mean position, will become positive and will become negative also. Because mean position we take as, if suppose we take mean position as origin, then for some time particle will go right side of the origin, but then again it will come and go left side of the origin. So then x will, sometime it will be positive, sometime it will be negative. Now angular frequency, what is angular frequency? Angular frequency you can call as that simply it is the rate of change of phase angle of the particle with respect to time. So d by dt of phase angle. What is phase angle? Omega t plus theta. D by dt of omega t plus theta will be omega, right? Which is the angular frequency. The rate at which phase angle of the particle changes with respect to time. That is called as angular frequency. Now the next is displacement in SHM. You already know displacement in SHM. Okay, everything is same. Let's go to the next. Velocity in SHM. So in the last class we also discussed velocity is nothing but first derivative of the displacement, you can say, and you will get this equation. So here it is a function of time. If you want to write it as a function of x, then you will have to do some manipulation. You will get this equation. This equation is velocity as a function of x. You can also plot this equation in graph. You will get this graph, elliptical graph, because you can rearrange this equation in the, it will come as equation of an ellipse. See, this is the equation of an ellipse. So this is the equation of ellipse. So the curve between displacement and the velocity of particle executing SHM is an ellipse. So this is important to do some graphical question. Many a time they can plot graph between velocity and displacement. You have to understand it will be elliptical of this shape. look at the equation. You can also derive the equation. From the equation, you can find the minor axis, major axis. Till now, there is any doubt?
No.
Okay. Now let's go to the next. Now let's talk about acceleration in SHM. You already know that acceleration can be calculated by differentiating velocity as a function of time. So dv by dt, already we calculated the velocity as a function of time. This is velocity as a function of time. If you differentiate, you will get this. This is the equation of acceleration as a function of time. But here you will see that in the equation of acceleration, this term is coming, a sine omega t, which is nothing but the equation of the displacement. So directly you can replace a sine omega t by x. And then the equation becomes a equal to minus omega square x, where x is the displacement from the mean position. You can clearly see that it satisfies the condition of SHM. This equation is telling you that acceleration in SHM is always directed towards mean position because of this negative sign. And the second important thing is that the acceleration of particle executing SHM will be maximum at extreme position, because it will be maximum when x is maximum, and maximum value of x is amplitude. Are you getting? At mean position, x will be 0, and so acceleration will be also 0. But this is not, it will be also 0, and it will be minimum at mean position. Also, you have to understand that mean position is that position where net restoring force becomes 0. So force 0, then acceleration automatically 0 from Newton's law. Now in this slide, you have any doubt, you can ask.
No.
This is the graph between acceleration and displacement. This graph is clearly showing you that this is the equation of a straight line, y equal to mx, where m is minus omega square, which is negative slope. Okay. Now we are going to talk about the energy of a particle in SHM. Here you have to understand that a particle which is doing SHM is in a stable equilibrium at the mean position, because when you displace the particle little bit from the mean position, it returns back towards the mean position. It proves that the particle is in a stable equilibrium at the mean position. Now, you know that potential energy is always defined for the conservative force. And here you can see that the restoring force that is acting on the particle is definitely will be some conservative force, because then only there will be a potential energy associated with it. Now you know the relationship between the potential energy and the conservative force. So that conservative force is here the restoring force. F equal to minus du by dx. If you rearrange and integrate it, you will get the function of the potential energy. Here you already know that in SHM, force is directly proportional to displacement from mean position. So F equal to minus kx, where k is not a spring constant. That you have to understand. It is not only for a spring. K is any constant. Are you getting? Don't understand that this formula came from Hooke's law and this is a spring constant. No, this k is any constant. Means what? If the equation is F equal to minus ax, then if this force is acting on a particle, the particle will do SHM, where a is any constant. In place of a, they have written k. That's it. Don't think that it is a spring constant all the time. So it is just a constant. So here, if you substitute this, you will get this equation u equal to half kx square plus c. So this is the equation of the potential energy. Don't forget this term here c. Okay. You don't know that the potential energy at the mean position will be zero or not. That you don't know. Because potential energy at the mean position can have any value. Yeah, but the only thing is that it will be minimum at mean position. Minimum. But maybe the minimum value is not zero. Are you getting? Maybe the minimum value is u naught. So the correct equation of the potential energy is this. Many times a student make mistake. They simply write half kx square. That is not the correct equation of the potential energy. Equation of potential energy will become half kx square if it is known that potential energy at the mean position is zero, or if there is some assumption is taken that okay, I am assuming that potential energy at the mean position is zero, then only. Otherwise, nowhere it is written that potential energy will be always zero at mean position. It will be always minimum. So see here it is written that when potential energy will become zero, when at the mean position, then only you can say this is correct. Are you getting? Tell.
And
You can ask your doubt.
not actually.
Okay. So if there is no doubt, we will go to the next. Now, in terms of time, so no problem. Just in the equation of potential energy, x is there. So just substitute x as a sine omega t plus phi. That's it. Just now we derived an equation. Now see, now onwards, they have removed that constant u naught, and they have assumed that okay, at mean position potential energy is zero. So that thing will be clear in the question, that whether it is zero or not zero. If that is not clear and the question is asking that what is potential energy, then you have to be careful. Don't take the potential energy at the mean position always at zero, unless and until it is clear from the equation or something given in the question. So in place of x, just substitute the equation of x for SHM. You will get the equation of potential energy as a function of time. Tell me, in this slide, you have any doubt? You can ask.
No doubt.
Okay. So then I'm going to the next. Now here you can see that the equation of potential energy as a function of displacement, if you see, it is a quadratic equation. And you know quadratic equations represents parabola. So the potential energy is minimum at mean position, and potential energy is a parabolic function of displacement. Potential energy is a periodic function of time. And here you have to understand that potential energy also oscillate. So oscillate means what? That when the particle is doing SHM, potential energy becomes minimum, then maximum, then again minimum, then again maximum, then again minimum, like that. Keep on fluctuating. So when the particle completes one oscillation, the potential energy completes two oscillations. Because you can see that the equation of potential energy is sine square omega t. Are you getting? It is not sine omega t, it is sine square of omega t. Whereas in the equation of displacement, there is sine omega t. So many a time this question is also asked that what is the frequency of oscillation of potential energy and kinetic energy? Answer is frequency of oscillation of potential energy and kinetic energy is twice the frequency of SHM. Because the frequency of sine square or cos square is twice the frequency of sine or cos. Are you getting it? You can ask your doubt.
Some getting somewhere.
Okay. So screen is visible to you?
It's just still visible.
So now the next we are talking about kinetic energy. So when the particle is doing SHM, you saw that potential energy is a function of displacement. Similarly, kinetic energy is also a function of displacement because velocity keeps on changing. Why velocity keeps on changing? Because of the restoring force, because there is acceleration. How to find kinetic energy? Simply half mv square, and you already know the equation of v. Substitute and you got the equation. If you want that I will find the equation in terms of time, then here in place of x, you just substitute a sine omega t plus phi. That's it. If you will substitute a sine omega t in place of x, you will get the equation of kinetic energy in terms of time, which is this. Look at this derivation and ask your doubt. Look at the graph also. The graph between kinetic energy and the displacement represents a parabola, downward parabola, because look at the coefficient of x square is negative here. Also look at the graph of kinetic energy as a function of time. See, when you write it as a function of time, cos square is coming. So look at this graph. This graph shape will be the shape of a cos square. Because here in the equation, all the other terms are constant. Constant into cos square, omega t. So this is the graph of cos square. Tell me, you have any doubt in this? You can ask.
No doubt.
Okay. Now comes total energy. Total energy, you will simply add the kinetic and potential. When you will add the kinetic and potential, you will get the equation of the total energy. And you will find that at the end, the equation that you are getting is half Ka square. Now in this equation, K is constant, A is amplitude, it is also constant. So total energy comes out to be constant. Total energy in SHM will be constant, assuming that there is no any dissipative force, there is no any resistive force. So all the forces are internal conservative. So mechanical energy will remain conserved if all the forces are internal conservative forces. So now let's try some questions. So let's start with this question. Very first question. Try this question. And you can ask your doubts also. Question is visible to you?
Yes, sir. Question.
Try this question and you can ask your doubt.
Yes, sir. Sir, it's 2 sine 33 by 10t plus 3 pi by 2.
Yeah, tell me.
Sir, it's 2 sine 33 by 3, 3.3 into t plus 3 pi by 2.
One minute. So the correct equation described. Yeah, tell me the equation.
Sir, 2 sine
2 sine.
3.3 t plus 3 pi by 2 or minus 2 cos 3.3 t.
Tell me the first one. 3.
Sir, sir, what's sir?
Tell me the first equation that you said.
Minus 2 cos 3.3 t and 2 sines 3.3 t plus 3 pi by
3.3t plus
3 pi by 2.
3 pi by 2. Okay, so 1 minute. Hmm. Okay, so 3.3t, you are saying omega t, and what is omega? 2 pi by t, and what is time period here? The time period is, uh, okay, so this half is 0.3 pi, so the full is 0.6 pi. So 2 pi by 0.6 pi, right?
Yes, sir.
6 pi. Then pi will go, and then you will get, so 20 by 6, right? Which is 10 by 3. Yeah, so 3.10 by 3 you can directly write. So omega t plus, you are saying 3 pi by 2 you are taking as the initial phase. Yes, because sine 3 pi by 2 will be a negative maximum. Um, Omega t plus sine omega t plus theta. Yes, so this is correct. And you can also express it in terms of cos. That is also correct. This initial phase t equal to 0, and this is nicely added. Correct. Equation is correct. Okay. So now you can go for this question. This one. Try this one. Are you getting the answer? Are you getting it? Are you there?
Hello, sir. Am I audible, sir? Hello. Hello, sir.
Yes.
Sir, average speed is 2 meter per second.
Average speed is 2 meters per second. So can you explain what you did?
Yes, sir. Given the equation of that x equals to 0.2 cos pi by t.
So you calculated displacement and then divided by the
Yes,
time.
pi meter.
Okay, you can try this one. If there is some other student he is also interested, then you can tell them also for JEE Advanced.
Yes, sir. Yes, sir. We can come. Second year, sir.
Sorry,
So for second year, sir, I just.
not getting what you're saying.
So you said another student is for
Yeah,
second year.
yeah.
Which year?
Another student, it will be better if it is a second year because then combined we can teach. We can teach.
Yes, sir. After this topic only we can start with the students. I mean,
Yeah. So if there is some other student, but the student should be of good level, like you and Imanish. Are you getting?
yes, sir. Okay. Fine.
So if there is some other good student want to study, you can tell them to join.
Yes, sir.
Okay, so try this question.
Yes, sir. Fine, sir.
Are you getting the answer? Tell me, are you getting the answer? Not getting?
There is a third one I'm looking third question. And two
Okay.
down pending. Your equilibrium pressure 2 meters.
So equilibrium is 2, that is correct.
The time period is root 2 pi.
1 minute. Time period is time period is tell me.
So the motion is simple harmonic motion, right? And the time period of this motion is root 2 pi for the second one, sir.
Root 2 pi you are saying?
Yes, sir.
Root 2 pi. Pi is also inside the root?
Then also outside the root, sir.
Okay. So root 2. Yeah, that is correct. Correct. Okay, and third one?
The third of two roots, sir.
Got it?
Got it, sir.
Okay. Okay. Uh, now you can try this one. This is from Ellen material. Try this one. So here you have to understand that here which type of SHM will be there, angular or linear.
Angular motion.
So it will be angular. So just remember the equation of the angular SHM. You know. So in angular SHM, process is exactly same here also. That, but in place of force there will be torque, and you have to prove that torque is directly proportional to the angular displacement. And again here the form will be that alpha is equal to minus omega square theta, from where you will find omega square, and then you will get the time period. Tell me, are you getting it?
It's the last chapter.
Okay.
Are you getting?
Sir, hello, sir.
Hmm. Got the
Sir, root
answer?
18. Sir, root 17 G by 18 L. Sir.
Root
Root 17 G by 18 L.
17 G by 18.
L. Sir.
18L. Okay, so just tell me the equation that you have written. Torque equation.
Hello, sir. Yes.
Hmm.
Sir, minus 2 mg. Sir, torque with that, sir. Minus 2 mg by sin theta, sir.
Minus
And
2
the torque
mg
by into sin theta, sir.
by
Equation is 17 by 12 mn square theta equals to minus 2 mg by sin theta.
minus 2 mg by sine theta.
Yes.
How you are getting this minus 2 mg by sine theta?
So, so this is a torque motion. I am applying torque equals I alpha. The torque is minus 2 mg by sin theta, so therefore. And I am equating to this I alpha. Sir.
Why you are saying minus 2 mg? 1 minute. Two identical rod, each of mass this.
Two rods. Sir.
So you are saying 2 mg by sine theta by sine theta, right?
2 mg is by sin theta, sir. Into, so multiplied by
Into
2 mg by sin theta equals to 17 by 12 mn square theta.
17 by 12
Ml square theta.
ml square theta. But how? What is this 2 mg by sine theta? Again, read the full equation. Read the full equation again.
Sir, it's minus 2 mg by sin theta
Okay.
equals to 17 by 12 mn square theta, sir. This is the
What
torque.
happened to
So
what?
this is
What
the
is
torque,
this?
sir.
This is the torque.
Torque.
So where is L? Where is distance in torque equation?
Yes, sir, I'm saying it's not. It's minus 2 mg by sin theta, sir. I'm saying
Yes, minus
not.
2 mg by sine theta. Where is distance? L.
So why not, sir? It's minus 2 mg L sin theta. I'm saying, sir. Mg into y sin theta.
1 minute.
It's not correct equation, sir.
You are saying minus 2
2 mg y
mg
sin theta.
mg by
Mg
sine
y.
theta.
So now mg multiplied by y sin theta, sir. I'm saying.
So why you are saying by sine theta? Mg sine theta directly say.
Huh, not sir. I'm saying multiplied by, sir.
No need to say multiply by. Only say minus 2 mg sine theta.
Yes, sir. Yes, because
Again read
that is
minus 2 mg sine theta. Read complete.
into y, sir. Into y. The
Into y, and
displacement I'm making.
what is y?
Sir, I'm asking that displacement of the body, sir.
Okay, and this is equal to something.
I alpha, sir. That is 17 by 12 ml square theta, sir.
And what is y here?
Sir, this is the displacement of center of mass I'm considering, sir. Below the
Displacement of
point.
displacement of the center of mass.
Yes, the center of mass, sir. Yes, sir.
It is displacement of center of mass or position of center of mass. This distance is from where to center of mass? Where to center of mass? Where to where?
From point S, sir. I'm assuming that point, sir.
Which point?
Given as that hinging point, sir. Hinged point.
As hinge point as?
Sir, yes, sir. From that, yes, sir. I'm saying the distance of center of mass. Means like position, we can say.
Okay. So that you are saying. Okay. Okay. And then on the other side, what you did?
Sir, I equate it to I alpha, sir.
So if you equate it to I alpha, then what you did, what happened to y? Then what is your final equation after simplifying this?
Sir, we get y as 3 by 4 L, sir.
Okay. So y is 3 by
3 by 4 L. And by using parallaxis theorem, we can find the moment of inertia also.
okay. So that is okay. Now it is okay.
Yes.
Okay. You use parallel axis theorem to determine the
Yes,
moment
sir.
of inertia about the hinge, axis passing through the hinge, right?
Yes.
Axis passing through center of mass. Which point you have taken?
Sir, what's
You calculated moment of inertia about axis passing through,
center, sir? How about the center?
and not about the hinge, right?
Yes, sir, not about the hinge, sir.
But why you have not taken about the hinge? So that is wrong, no? Because the theta that you assume is the
With
displacement
the
with respect to the hinge.
sorry, sir. Yes. Then with respect to hinge, we can consider an equate now.
Yeah, so then it is not correct. So see, this is the answer. Are you getting this?
Yes, sir. Um,
You are not getting this.
not taken. 1 minute,
So,
cinema.
because you have taken the displacement
With
about the
respect
axis
to
passing through the center, you have
center.
to take about the axis passing through hinge.
Yes, sir.
Also, the torque that you are calculating. Okay, you are taking that one. Without finding center of mass, also you can do. So, if it will be here, then this will be like this, right? And then two forces will be acting. One force will act on this here, and one force will act on its center of mass here. Are you getting?
Yes, sir. I'm getting.
Two terms you will get. Torque due to this plus torque due to this, both you will add separately. Both rod mass is identical, so mm you can take. So no need to find here center of mass of the whole system. You can simply write mg into L sine theta plus mg into L by 2 sine theta. Are you getting?
I'm getting, sir.
And that is equal to I alpha. I, you have to always find about the axis about which you have measured this theta. So it should be about the point of suspension. It is doing, the whole system is doing SHM about the point of suspension.
Yeah, got it.
Are you getting it?
Yes, I'm getting.
Okay. So let's go to the next then. So let's try a few JE questions now. Yeah, this is a very interesting question. This one. Try this. IT JE 2009.
So question is not visible. The previous question
Sorry.
only visible.
Sorry.
The previous question only visible, sir.
Okay, 1 minute.
Yes.
Now check. Now.
So now it's visible, sir. Now I can see, sir.
Try. Are you trying? Are you getting? Are you getting answer? Okay, try. Are you trying? Are you getting?
Um, So option D, sir.
Option D you are getting.
So Delhi.
D option, right?
Yes.
D you are getting. Can you explain the process what you did?
So simply, we know that for F equals minus K. We're
Okay.
finding both forces.
And then what you
Then
did?
finding the force, we can say this series combination. We can write that force equals to K1 K2 by K1 plus K2 into N.
Uh, yeah, correct. Okay, then.
We know the amplitude will be force by K. We can write also K1 of the point P means.
So amplitude will be, you said force by K equivalent. That you are saying.
Yes, sir.
And what is force?
The force by K1, sir, because the point attached to the consisting K1. Sir.
Again, what you said, amplitude is equal to
The amplitude equals to effective force by K1 answer.
F effective by K1 you said. Okay, and what is F effective?
K1 K2
You
by
combine.
K1 plus K2 into S.
Yeah. Okay. Okay. That is the correct answer. Now you can try this one. So now keep solving questions from your Narayana material from SCV. Okay. You can ask your doubts. You can ask your doubt. This JE 2009 question.
So Chennai.
Which one?
Yes, sir.
Option
Yes, sir.
C. Option C, right?
Yes, sir.
Correct. That is the correct answer. Okay, so again here you applied angular SHM concept, right?
Yes, sir.
Net torque equal to I alpha. And I you have taken about
The point 0.07. I think that's right.
this point, center. Which point you have taken? I you have taken about
About one end of the strings I have taken. Moment
sorry
of inertia.
about
So the above end of the strings.
means this end you have taken. Where you have taken I you have taken about moment of inertia about axis passing through about which axis you have taken. Moment of inertia you have taken about which axis?
About that point, sir, which is the dot mark we can say.
Okay, about the center. Center you have taken, no?
Yes, sir.
Have you not taken center?
Center.
You have taken center, no? So then why you are not able to express clearly? Pivoted at the center. Okay. So that is correct. Okay. That is correct. Okay. So now you can go to the next. And this is again a PYQ ITJE 2015 question. Try this one. Momentum versus position graph is there. Momentum versus position graph. Is it visible clearly? Momentum versus position graph.
Yes, sir. It is visible, sir.
Okay. So then try this question. So you can write velocity as a function of x equation, and then momentum is nothing but mass into velocity. So momentum equation you can write, and then momentum as a function of x. You will see that the equation will be equation of an ellipse. So getting the equation in proper ellipse form, you will get the value of A and the value of B. And after getting value of A and B, and R, you will get the N value. So try.
Sir, B D.
Which option?
Sir, B D.
B and D you are getting. You are getting B and you are getting D. So this is question number 15. That is the correct answer. Good. So just like this, keep solving. You are already doing good. And all the concepts are, I think, covered, most of them. So you can take this question as your homework. Okay. Or if you want to ask anything, you can ask.
Tomorrow I will have doubts, sir.
Okay. So take this question as homework, try this question. And okay, we'll continue tomorrow then. When
Sir, okay.
when you want to start combined class, when Himanish will be free?
Sir, I said after exams only, sir. 2 days pending for exams.
After
Sorry.
2 days.
Yes, sir.
Okay. Okay then.
Yes, sir.
Okay, bye.
Yes, sir. Thank you, sir. Thank you, sir.
Okay, all the best.